In class activity 18D, equations of circles. The boundary of the service range of a certain cell tower can best be described by the following quadratic equation: x squared plus y squared plus 2x minus 4y equals 0. Part A, what are some points x, y which satisfy this equation? Well, there's many points that would satisfy this equation. But for, there we go. This is going to write for part A, 0, 0 would satisfy the equation. Let's see, if we put -2 in for x, then that would leave 0 for y. We could do 0 for x, then 4 for y, and then something like -2, 4 would satisfy that equation as well. Part B, predict the shape of the graph of this equation. Well, if we're going to predict this for part B, the graph of the equation is a circle. Objectives for the activity. You will understand that some quadratic equations have graphs which are circles. If a quadratic equation describes a circle, the center and radius of the graph of a quadratic equation can be determined by writing the equation in standard form. You will be able to determine the center and radius of the graph of a quadratic equation when the graph is a circle. See that different forms of the equation of a circle tell us different pieces of information, and sketch the graph of a quadratic equation corresponding to a circle. 2. You may have predicted that the graph of x squared plus y squared plus 2x minus 4y equals 0 is a circle. We wish to determine the exact location in yards of the cell tower, which is at the center of this circle. Part A, what format should we write this equation to make it easy to identify the center of the circle? Well, we could write it as x minus h, quantity squared, and plus y minus k, quantity squared, equals r squared. Part B, it asks us to rearrange the left side of the equation so that all of the x terms are together and all of the y terms are together. So we could do this, we could write it as x squared plus 2x, they're together, and then plus y squared minus 4y, and then still equals 0. Part C, it says, using your work from question 4 of preview assignment 18D, replace x squared plus 2x and y squared minus 4y with their completed square versions, x minus h squared plus k. And when we do that, we have x plus 1 squared minus 1 plus y minus 2, that quantity squared, minus 4 equals 0. Part D, collect the constant terms in your equation above to the right-hand side to obtain an equation of the following form. So we could do that. We could write x plus 1 quantity squared plus y minus 2 quantity squared equals 5. Part E, what are the coordinates of the cell tower? So the cell tower is located at -1, 2. And that comes just from looking at the equation that we wrote in part D. So let's scroll down 1 second. Number 3, local city officials wish to issue a blizzard warning to residents in the area. On the axes below, sketch the circle found in question 2. Recall that this circle describes the boundary of the range of the service for this cell tower. Well, the center is going to be at -1, 2, right here, there's the center, and square root 5. There. So really rough looking circle. Not like that. And fortunately, I have a better drawing of this. Well, I didn't draw it, but it's going to look like that. Part B, will a person located at the coordinates 1, 2 receive a ping from the cell tower? Well, if we go back here at negative, a person at 1, 2, yes. So we can answer yes here. That's within the circle. So part 2 or C, will a person located at the coordinates negative 3.5, 1 receive a ping from the cell tower? Negative 3.5, 1. No, that's going to be outside the circle. So part C is going to be no. This is out of range. Part D. How close must a person be located to be pinged by the cell tower? Well, the person must be within the square root of 5 of the cell tower. Let's go to the next screen. Questions 4 and 5. It says cell tower triangulation. This is a method used to determine someone's location by tracking the cell towers that the cell phone pings and looking at the overlapping region within the tower's ranges. In the next 2 questions, we will try to retrieve a lost phone by looking at the ranges of the cell towers it pings, but we need to be able to draw the circles first. Part 4, number 4, it says, suppose the lost phone pings 3 cell towers. The first is the same tower used in questions 2 and 3. Part A, the boundary of the second cell tower is given by the equation x squared minus 6x plus y squared is equal to 7. Convert this equation into the form x minus h squared plus y minus k squared equals r squared. Follow the steps you took in question 2. Well, what we're going to end up with is x minus 3 squared plus y squared is equal to 4 squared. Part B, the boundary of this third cell tower is given by the equation x squared plus 4x plus y squared plus 2y equals negative 1. Convert this equation into the form x minus h squared plus y minus k squared equals r squared. Follow the steps you took in question 2. What we're going to end up with here is the quantity x plus 2, and that's going to be squared, plus y plus 1 squared is equal to 2 squared, or 4. Number 5, you have enough information to locate the phone. Part A says draw the circles describing the range of each of these 3 cell towers on the axes below. Well, if we draw one at the center, negative 1, 2, and we draw this again. So there's one circle. And then let's draw another circle. How about a 3, 0. There we go, and negative 2, negative 1. There's the center, and we're going to go up 2. All right. Now, fortunately, I have a better drawing of this, or like that. And the next part, it's just asking us to shade the region in which the phone is located if it pinged all 3 cell towers. So it looks like it's going to be the piece right in here. And you can see on that graph, that would be the same Oops, that graph, it would be the same. All right, that's the end of this video. Thank you.